Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just resolved on my own after over a year. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this problem without any assistance after over a year. So let's go over it and let me show you how I did it. So this is question 624, maximum distance in arrays. So basically you just want to see the biggest difference you can get from any element in any array, basically as pairs. So in this case, 1 and 5 have the biggest. And so just from this, you can tell we're probably going to want to sort the arrays so we can get the biggest and the smallest, and then here's biggest and smallest, and compare to see whatever biggest difference we can get from separate subarrays in this matrix. So let's do exactly that. Let's call .sort on arrays so that we sort everything in ascending order. Okay, so now let's go ahead and just compare every single element. And as I said, because we're looking for pairs, let's call this val is float of negative infinity, and we're trying to maximize the distance and return that maximum distance. We're going to maximize value, and it has to be the absolute difference. It says right there, between arrays I of 0 minus arrays j of -1. So the smallest here, the biggest there. And then let's also try the biggest here minus the smallest there. Right? So just trying all the combinations that we can get. And then at the end, we can just return that value. Right? So let's run this. Submit it. So this is fine. But it's n squared, and that's not going to work for this kind of input. So it could be up to 10 to the power of 5. So you get time limit exceeded. So let's try something a little different. Since we're trying to check every other pair, and this is already in sorted order, why don't we just scan the array once? And then just keep track of whatever the smallest and the largest of everything we've seen so far. Because if we're on this one, we're only going to have historical information from these. If we're on this one, we're only going to have the biggest and largest historical information from the ones to the left. And then we can just compare that with the current elements. Current elements, smallest and largest, right? So that's the important point that I came up with, is that you need to just keep track of the historical information because this array is already sorted. So by the time this is going to be here, by the time we get to 5, we're going to see that the smallest we've seen is 1, the biggest we've seen is 3, right? So if we print arrays, that's what we're going to see. And then we can just, while we're here, we compare this and the smallest, and then we compare this and the largest, and that's going to give you 4 as the answer, right? So that's kind of the thought process that I came up with. So let's go ahead and try to code it up. And let's call this smallest and largest let's make 2 sorted lists. And then we're just going to add the smallest, which is arrays I of 0, because these are already sorted in ascending order, each sublist, right? And then the largest, we're just going to add arrays I of -1, because we know that the rightmost element of each sublist is bigger than or equal to the smallest element. And then here, we can just say if the smallest list exists, then we maximize value and arrays of I of 0 minus smallest of -1, so absolute values. That's just one of the combinations. And then if largest, again, absolute of arrays I of 0, so the current smallest, if we're here, we're at 4, 5, it's supposed to be this position. We're subtracting largest of -1, right? So, and then again, the current smallest and the smallest here, and we can also say the current largest minus, or the current largest minus the historical smallest. So we're trying to check every single combination, right? And then we got the current smallest minus the historical largest. We're trying to maximize that difference, right? So let's go ahead and submit this. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this problem without any assistance after such a long time. So that's it for this video, and thank you for watching.